This is one of my favourite map interpretation exercises that deals with thrust tectonics. It was put together by Derek Powell many years ago and I modified it a bit. It's hypothetical, so it's not a real world map, but it introduces a whole pile of really useful techniques that are very applicable to the real world. So let's get on and see how to take this map apart. Well, our mission will be to draw a cross section through the map, passing through this blob here, but at this stage we don't know which direction to draw the cross section. Is it here or here or here? Which is the most useful way to portray the structure? Well, we'll need to do a bit of map analysis to make that decision. But before we go that far, let's first of all think qualitatively about what's going on. So I want to try and sketch a cross section to get a feel for the overall structure. So, where are we going to do that? Well, I'm going to look at the map and I can see the topography. I can see there's a big valley down here with this drift. I can see that there are contours running all the way along here. So that's a long valley side running along the map. There are other subsidiary valleys, aren't there? So I can see another loop here of the 200 and 300 metre contour, a ridge line, another valley. So we've got some rather strange outcrop patterns in here, these sort of horseshoe shapes or crescents. That seem to broadly relate to where the valleys are. Well, we'll worry about those complexities later. This is the hillside that provides the most useful information, that gives us a nice swathe across the map. So to avoid confusion, let's just cover up those bits of the map that we can't see. We'll imagine ourselves sat here looking across the valley. So let's just cover up this far side of the map because we won't be able to see it if we were sat in the valley bottom. So this is a natural cross section. All these topographic contours are running across like this from relatively high ground. In fact, this is a reasonable ridge line to the valley bottom. So let's try and sketch this profile. So we're stood here looking across and the valley bottom here is more or less the same elevation all the way across. Let's just draw that in. There's our valley bottom, and we can see up here we've got some higher ground that comes down like this. So we'll just draw some higher ground coming in something like that through the top. So there's our topographic profile. And the next thing is that we can see as we walk up the hillside here, we go from this pink material through this white bit to a yellow marker, through to more white to green. And this yellow marker through here is contained within the 200 and 300 contour, so it's essentially, in our view here, apparently horizontal. So I'll just draw that in like this as our horizontal marker in the yellow. And all the way across here, the contact at the base of the white goes all the way across. So that's going to come all the way across. So there. So that's our yellow. And the yellow comes along to terminate about here. So I'll just draw that in to there. And then I can see the white unit comes up and across like that. The yellow then climbs up and over like this, so that in a profile through here, if we walk up this hillside, we'll encounter the yellow unit twice. So let's say that's here. So we'll say that we'll encounter the yellow unit twice here. So there's the yellow unit coming around, something like that. And it comes back down to lie between 200 and 300 meters. So down something like that. Okay, so let's just color that in to see what we've got so far. Okay, well, let's keep going. And we can see that this package in here continues across and then stops around here. So let's do that to about here. And then in this position again, if we were to walk up this hillside, we'd encounter another piece of the yellow unit higher up. So we've got this panel here that's coming down like this. So and it disappears off the top of our cross section. So it's going to come down something as we have the contact like this, and we have here this piece coming down something like that. Okay, so that's this yellow unit. Again, let's just colour these up. And I'll just snap this against this contact here. Okay, so we've got what we've got here is this front piece of the, on the left hand side of yellow unit. The yellow unit come up again here, which is that piece, and this one here which comes right to the top to there, and this in turn comes down to here. Again, interesting that it still lies, when it comes back down, it lies between 300 and 200 meters, 300 and 200, 300 and 200. So these are all coming down to the same sort of elevation towards the bottom of the valley. But this piece here stops. So again, it terminates here. If we walk up this side, we're going to go from 200, 300, 400, 500, and we cross this structure here. And we can see if we follow this yellow band up, it's climbing up the hillside and then drops a little bit down. So we've clearly got some kind of upward closure or an antiformal structure here where the yellow horizon or the yellow unit climbs up and down. So that in here somewhere, I'll just draw that on, something like that is the form, whoops, let's do that a bit better, the form of this bit of the yellow unit here. And again, it's coming back down towards 200 and 300 to line up with the others in here. And there's a contact that terminates the yellow unit here, which seems to come down like that. Again, let's just colour this up. So pretty obviously we've got some fault structures here which are stacking up the yellow unit, so that it's moving up like this, and then again like this to carry that one up, and this like this. Where do these faults go? Well, they don't keep cutting all the way down because this contact here is not offset. So yes, these faults must come back down and run on a structure that's coming through like this. So these faults have to come down and come down through here and presumably join up like this. So we have a basal detachment, this looks like a floor thrust, doesn't it, climbing up and making these imbricate thrusts that stack up the yellow unit. Now let's look at some of the other stratigraphy, and we can see as we go up the hillside here, we go from yellow through white to green in the same way as we went from yellow, white, green up here. So on this part of the hill we can see that this boundary at the edge of the green climbs up and down, following the shape of the fold structure we've just drawn in the yellow unit, and it drops back down to here. So somewhere sort of like this, I haven't really got enough space, maybe I'll just adjust my topographic profile so I've got a bit of space to put the green unit in, something like that. So I have lots of green here climbing up and over, and it comes down against a contact here. So the green is only in this piece. I'll just colour that up again. So there we have this package of the green rocks coming over the top, making this carapace or cover to the fold structure coming over. Don't have any green in here. Next bit of green's just in this position. The boundary in this here is running between 300 and 400, then climbs up to the edge of our cross section. So presumably the green does something like this, comes across, and then in this position climbs up. So again, let's just colour this in here. Finally, let's just emphasise the fact that the underlying structure here shown by this pink wash that lies just outside the bog is not involved in the structure, so we should colour that lot in at the base as well. So it's quite an interesting structure, isn't it? What we've got here is our panel of stratigraphy here, the yellow units coming in, being caught up on a thrust structure, carried up, another thrust here, another thrust here, these thrusts merging down onto a basal detachment or floor thrust, not cutting deep into this package in here. So essentially it's a thin-skinned thrust system, only skin deep, doesn't involve the basement rocks. Well, there's a little bit more we can do now. What happens to this thrust here? Well, as we look out, it looks like it goes on through here. So just to finish this up, this thrust goes something like this and out. So the displacement would have continued here and out of the side of the section. Have we got everything on here now? Well, we've got the yellow units, the green, we've got these contacts here, these ones here. Oh, look, there's a little piece here we haven't got, which looks like it joins the edge. So there's some sort of structure here that we've yet to identify. That point there being that point there. So here's our cross section. We can orient it because there's a north arrow on our map. So our cross section is running in this particular case from the northeast to the southwest. So I'll just label this northeast, southwest, and it's our sketch section. So we can use this to inform the interpretation of the map. So it's time to reveal the map itself. And see, we can use this to inform the map pattern over here. Let's just straighten everything up. Okay, well, let's start off by identifying some thrusts. So I'm going to draw them on. On here, this thrust comes down like this. This one comes down like this. This one comes like this. And they all run along this basal floor thrust. Let's take this information and transfer it onto the map. So remember, this point here was where we recognised the repetition of the yellow unit. So this is our thrust here, coming down, and it climbs up like this. So in this case, yes, the yellow unit's truncated down against the thrust like this, and the thrust continues to the side and comes down here to the floor thrust. We have this thrust here that comes down to the floor thrust. Let's bring it down. Rather scruffy drawing, and along. And then this one that comes down. So these are the thrusts that we've identified so far on our cross section. Well, let's keep going, because this thrust we can clearly see continues like this. This one continues a bit, and this one continues to there. Well, we've got a little bit going on here. Let's see what we can manage to see in the cross section. Well, I can see a footwall ramp and a hanging wall ramp, footwall ramp, hanging wall ramp, footwall ramp. Well, this should come down onto the thrust plane somewhere over here, and it's up in the air, but on our map is in this position over here. So as we go along this thrust, this yellow unit comes against the thrust plane here. Its matching footwall is there. Matching footwall, the hanging wall here would come down onto the thrust plane. We can't see it here. We can on this structure. We can see that there's our hanging wall termination of our bed against the thrust, and there's the footwall that it came from. So we can do a little bit on this. Let's try and push the interpretation a bit further. So remember, this is a view looking onto this hillside. If we were to drill through this hill and look up the next valley, we'd expect to see this structure come through again. And that's what we can see here. As we go over this ridge and down into the next valley, I can see that as we go up this valley, we cross the yellow unit once, twice, 3 times. And that would be the same as going once, twice, 3 times. We've already identified this thrust. It's that one here. So this yellow unit in its footwall is this piece here. So the thrust that carries it is this thrust. So let's just draw that around. Like that. And we can take it all the way to there. So that's pretty interesting. So we've seen this thrust is this thrust here. And we can see the same thing occurs in this valley over here. So as we go over this ridge, which goes to 400, 500, 600, that's a ridge line. We go over this side, this is a valley bottom. As we walk up this valley, we go through the yellow unit once at the bottom, continue along the valley, going slightly higher to yellow, and then yellow again. So 1, 2, 3, 1, 2, 3, 1, 2, 3. So this thrust is presumably this one here again. And what's more, this one is this thrust here. which repeats our yellow unit. So we can use our understanding from part of the map to continue our understanding through the rest of the map. But we've not finished there. Now, if this piece of yellow rock has been pushed over this one, all this package has been pushed up and over, which means there's been displacement carried along the base of the green. So our fault has to continue like this, out of section. Indeed, that's what we showed when we drew that little arrow earlier. Therefore, this thrust doesn't stop here, it continues around the green. I've got my cross-section profile in the way here. It's going to come around the green and continue like that. So our thrust continues. Similarly, as we come around here, this thrust will continue. Oh look, it will continue at the base of this washed out light green material and run all the way around to here and out again. So this thrust will continue. Similarly, this thrust slice that comes over the top has pushed loads of displacement onto this thrust. So this thrust keeps moving all the way. It won't stop there. Oh look, it looks like it joins here. Similarly, this one joins here and this one joins there. Finally, what about this thrust? Again, it's pushing displacement. It doesn't die out at the base of the green here. It's transferred onto the base of the green. So slip continues. So let's just put some arrows onto these to illustrate the fact the displacement continues. So this displacement will continue all the way along the base of the green. Oh, look where it's going. To join here. So similarly, that's going to come around and it's here, isn't it? So we've got this upper thrust slice in here, which we're not seeing through here. That's the thrust displacement or thrust surface coming around like that. We don't see this yellow piece in the hanging wall to the thrust here. It must lie back this way. And if we look at the map, oh look, there's a bit of yellow here. So maybe this structure continues in this trend. One more little bit of interpretation to finish up. And we've seen this piece of green here is detached and slipped from its underlying material because thrust displacement is arriving onto it here and from here. So therefore this piece of green is also slipped relative to the material underneath. So actually this is a thrust slice in here coming off thrust surface. This is a thrust surface as well. So let's just draw those on. Okay, so now we've interpreted the faults, the thrust faults, onto the map here. What we can do now is let's get towards this idea of working out how we're going to draw our cross-section through this blob. And we want to know the trend of the thrust, in other words, the trend of the ramp structures that climb across the stratigraphy. The best way of drawing a cross-section is perpendicular to the ramps. So how are we going to find out where they are? Well, we're going to draw some cutoff lines. Cutoff lines are where the stratigraphy comes down against the thrust plane. This is where the hanging wall in the yellow comes against the fault plane, so it's part of a cutoff line going in like this. That's where this unit comes down against the fault plane, so that would be the hanging wall cutoff, and that's the footwall cutoff. So what we're going to do is see if we can identify some of these places on the map. Well, let's identify where this place is on the map. We've already done that, and I'll mark it with a half circle, and it's here. And I'll just be precise. Let's just take the leading edge of the yellow. That's where it comes down against the fault plane, and it does it again there. So we can follow the top of the yellow unit around, comes against the fault plane there, come across over here, make sure this is the right unit because we come up across the first thrust we encounter up the valley, the first thrust, so yes, this is the first thrust. Here's the yellow unit in its hanging wall above the thrust plane. That's where the top of it comes against the thrust, there and there. So these places, 1, 2, 3, 4, 5, are all places along a line here, which represents where the yellow rocks come down against the fault plane, like that. So that is a hanging wall cutoff line. Let's draw it on. it tells us, and of course it continues, it tells us the orientation of this ramp structure in the hanging wall. We can do the same for the next thrust up. So here we have the yellow rocks coming down against this thrust. There's the leading edge of the yellow rocks coming against the thrust plane there, and it does it again there and again there. So this is the hanging wall cut-off line for the yellow rocks against this particular thrust here, which is this one. And it doesn't feature on our cross section because it's eroded and up in the air. Well, that's about as much as we can do on this part of the map. But actually, we haven't used the whole map. I've been obscuring part of the map on this side of the valley with my sketch section. So let's just take the sketch section away. That's better. So now we're seeing all this ground, and we've not interpreted this, but we can see the same sort of things going on where the yellow rocks are repeated on the hillside. If we walk up here, we'll see them 1, 2, 3 times up this hillside, and we can see that they're what look to be thrusts. Well, we know that we can identify thrusts now by their terminate, where they cut off the yellow unit. So let's see, we've got a thrust here, it's coming up, another one there, and there's another one here which is cut off in the hanging wall side of the fault. And let's just project these on. We can take these thrust structures down like this and up away from the valley bottom. And we've seen that these thrusts, it's this climb up and they run along the base of this green unit, so let's just do that. There we go. So we've got a quick interpretation of this side based on the knowledge we've gained from the other side of the map. Again, we can see that the yellow unit is coming down to lie between 200 and 300 metres as it comes back down towards the valley bottom, 200 and 300, 200 and 300, as it does on this side. So this yellow unit is essentially horizontal were it not for the thrusts. So this piece comes in and runs against the thrust here to make a footwall cut-off, and we can see it on this side of the valley. So let's just link up, and again I'll use the brown pen for that, and we'll use the top of the yellow unit against the footwall side of this thrust here, and there it is over here, just there. Okay, so this joins those up, and this makes a cut-off line for the yellow rocks against the thrust climbing up. So it's the footwall cut-off line. It's the mirror image, if you like, of the hanging wall cut-off line. They're basically parallel to one another. So let's see if we can find the footwall cut-off line for the next slice along. Well, the footwall to the next thrust slice is here. The top of the yellow comes in there. And we can find it on the other side of the valley, there. So again, this is the footwall cut-off line for the next thrust. So I'll label this footwall, hanging wall, footwall, hanging wall. Of course, these would have continued further. So let's just continue to extrapolate the footwall cut-off line here, and it lies buried beneath all this high ground. The hanging wall cut-off line has been moved across because of displacement on this thrust. So that gives us a measure of the horizontal component of displacement on this thrust. We can do the same for the frontal thrust by projecting the hanging wall cut-off line across here. And that separation, what's about 500 meters, is the displacement, or the horizontal component of displacement, on this thrust here. So the cut-off lines are really neat structures for telling us the trend of the ramps. We can do a bit more. Finally, let's just put in this structure. We can see where the top of the yellow comes down against that thrust there. We can see it over on this side. Join those up. That's the hanging wall, because it's in the upper side of the thrust. Hanging wall cutoff line for the yellow against this particular thrust. We can't find the footwall because it's not exposed on this side of the valley, but presumably it comes through and it's just off the map in here. Well, these cutoff lines are really useful, but we can construct some other features now. Branch lines, which is where two thrusts come together. Let's see if we can find these on the map. Well, there are quite a lot of places, aren't there? I can see that we take this thrust here, it joins the one that we've got at the base of this light green unit, and we can find it again over here. So these are two places where this thrust and this thrust join. Let's just make sure we can find these on the cross section before we go any further. Well, I think we can. It's here. So let's mark that point on the map where it occurs. Well, it occurs here and here, where the frontal thrust joins the one above. Okay, so that's pretty good, and we can see it must also occur there. 3 places where the underlying thrust joins the upper one, and again there, and again there. So this, which I'll just mark by a series of X's, is the branch line. This branch line here, where the frontal thrust joins the one at the base of the green coming down like this. So it's where two thrusts join. Well, we can also see that this thrust joins the upper thrust there. Oh, there, we haven't marked that bit of thrust yet, have we? Let's mark that on. Which is where this one's going to come round. So those are 2 places on that branch line. It comes out again there. Oh look, and it's there and there. So these ones, which I'll just dot, is the next branch line, BL branch line. Branch line. And we can find that on the cross section. It's there. So we've got a series of branch lines, 2 on the cross section here, and they'll be where this thrust and this thrust join the one that's coming over the top. So branch lines are other structural elements that we can use to define the relationship of the thrusts in 3 dimensions. Finally, let's put on the fold structure that we can see in the hanging wall to this thrust here. Again, from our cross section, it's this feature here. It's the hinge line, or the crest actually, of this upright antiform in the hanging wall to this thrust. And it's here and here. And that structure there is also on the same general trend as the hanging wall and footwall cutoff lines that we traced out, and the branch lines. So all our structural elements in here are aligned like this across the map. So from the northwest to the southeast. So that's our analysis of this map. First sight it might have appeared quite complicated because of these rather strange crescent shapes, which are because of the Ving in the valleys. When we drew our cross section, always a good thing to try and do to start with, a quick sketch section to get you into the geometry. The structure is relatively straightforward with these imbricate thrusts climbing up, and we can use that information to add precision to our map analysis by constructing cut-off lines and branch lines and even that fold hinge line. And we can now go on and decide to draw our cross section perpendicular to these trend lines. It's something we've already got more or less in the right shape with our sketch section, but now we can do a better job. We can honour the stratigraphic thicknesses, we can use the cut-off lines and the branch lines and project them onto the cross section and add precision. And that will be the next step in our analysis. So it's a really neat map. It may be hypothetical, but the ways in which we approach the analysis of thrust systems and the application of ideas of linked thrust systems on geological maps, well, it's a really neat example.